All right, so you saw how the Hello task looks like. Now we'll see how we build a reinforcement learning agent with this task. So in this task, there are two objects presented, and irrespective of location, a particular object is rewarded and the other not. Right. So you have to figure out over multiple repetitions of these trials where objects locations are switched, which object is the one rewarded. Right. And for the continual case, what you can do is you can present two objects for some trials and then present two new objects for some trials and then two more new objects. So you can keep going, and at some point you present the objects you saw on the first trials, right? And then you should still be able to know like what object corresponded to the reward. Because if you don't, then you catastrophically forgot, right? So that is what we will go towards. But first, let's see how we can formalize this problem in terms of reinforcement learning and what kind of agent we can train to do this task. So in RL terms, the agent is the system set of neural networks in this case, which would be given the state outputting actions, right? So the state is the current information about objects. So you'll tell the agent about what object you're looking at, what location, right? And then reward, you'll get a scalar corresponding to what's your choice, correct? So the choice is the action. There's two possible choices, left and right in this case. The question is, how do we build an agent to do the Harlow task, right? What kind of RL agent would be good here? So what we use here is the advantage actor critic algorithm. We won't go into too many details, but basically what this algorithm does is the agent gets two networks. One is the actor network and the other is critic network. The actor network gets the observations from the environment, which contains the state and all that, right? And so actor takes the observations and then outputs actions. So that interacts with the environment. The critic also receives information about the observations and also what action the actor took, and then estimates the expected reward from this particular state action pair. So that you are in a state, you took an action. In the future, like you will take more actions to reach your goal. So what do I expect currently given the state and the action I took? My expected reward in the future. That's what the critic does. And then the actor basically learns to create actions which maximize expected reward. By receiving reward feedback, which we also get from the environment, it will learn to select the action that returns this reward. This is used in much more complex settings than the one we are entertaining here, but this is also to introduce you to, let's say, state of art method in RL. And we'll see in the next video that this is going to constitute the inner loop in the meta reinforcement learning framework, because this agent is really training on a specific task we gave it right now. This sequence of trials where there are two objects and then they keep switching and then you get some reward. So before we go into the continual learning details, first let's build this RL agent and then see how well it can even perform on the Harlow task without any meta learning. Right? Then once that's set up, we can get